In this video, we're going to look at using synthetic division to divide a polynomial by a binomial. And this is sometimes called Ruffini's rule. So the idea is that this was discovered, not invented, by an Italian mathematician named Ruffini in the 1800s, early 1800s. But in actuality, this way of dividing and representing a division in a very efficient way was actually seen much earlier in the 1200s in China, and even before that in Persia in the 1100s. So even though it has been given Ruffini's name, it did not originate in Italy. Okay, so the process is the following. I want to divide by x plus 3. So the first step here is to take the x plus 3 and set it equal to 0. And then isolate for x. So that's x is negative 3. So this value of negative 3 is going to go outside. I'm going to create a matrix. And a matrix is really just a grid. It's a way of organizing numbers that is neat and easy to follow. So this grid is going to have a shape that looks like that. And along the top of the grid, this is actually 2 rows inside here, I'm going to put the coefficients of each of these terms. So I'm taking pause, make sure they're in descending order, and they are. They go from power 4, 3, 2, 1, so that's a linear term, and then the constant, so I can proceed. So I'm going to write my coefficients along the top here. So I've got 3, 7, negative 1, negative x squared is negative 1x squared, 14, and negative 3. Okay. Now, the first one is just going to drop down as is. Next step is to multiply. So even though this problem says we're going to be doing a division, what's nice about synthetic division is that it flips it on its head, and we're going to be doing multiplications and additions, which I hope you agree with me, those are simpler to do in your head than divisions in your head. So that's the power of this method. Negative 3 times 3 is negative 9. That number goes in this position under the 7. And then I add in the column. So 7 plus negative 9, or 7 minus 9, is negative 2. And then I repeat. So negative 3 times negative 2 is 6, positive 6. And if it helps you to not make any mistakes with your additions, you can add, whether it's a positive or negative, you can add that sign. So now negative 1 plus 6 is 5. And then negative 3 times 5 is negative 15. 14 plus negative 15, which is the same as 14 minus 15, is minus 1. So I'm doing in each column as I come down, I'm adding. I just add the two values together to get the number that's under that line. Okay, last step, negative 3 times negative 1 is 3. And this last one, I'm going to make a little cell for it by adding a bar there. Those add to 0. Negative 3 and 3 add together to 0. So that's actually super important. If I do a synthetic division and I get a 0 in this last position, that means that there is no remainder. Meaning that when I divide the polynomial by the binomial, it goes in completely without any remainder. So from that, I can write 2 different statements. I can say that my original binomial, which was x plus 3, is a factor of that polynomial. But that's not all. In these values that are underneath the bar, there's more information. So the 3, -2, 5, and -1 are actually the coefficients of the quotient, or the answer. So 3x to the 4 plus 7x cubed minus x squared plus 14x minus 3 divided by x plus 3. The answer to that, or the quotient, is constant of -1, linear term is 5x, quadratic term is -2, and then cubic term, 3x cubed. So notice it's descending order of powers of x in my result. So the 3, -2, 5, -1 came from underneath this bar as we went through. So it's giving me 2 pieces of information that are quite useful. I could also rewrite it as a multiplication statement. So I could say 3x cubed minus 2x squared plus 5x minus 1 times x plus 3 equals my original polynomial, which is this quartic. Like that. This is a 2 here. And that is synthetic division, or Ruffini's rule.